Thank you for listening to my talk. Okay. In today's keynote, we heard that quality is often only an afterthought, and it has to be taken into account. It should be taken into account upfront, and it would be best to build it into the process. And I want to show you how you could use the Sonar ecosystem to help you with that. I work for FluidTime, which is a company based in Vienna, and we build mobility services that tell you how to come from A to B. I'm the CTO of FluidTime. What I also wanted to tell you about is how did I end up here. Approximately 2 years ago, I decided that I wanted to get closer to the developer community, and I signed up for all the meetups I could find, all the conferences, but actually I never visited any one of them. And then something, a miracle happened, more or less. In 1 year ago, the Java Vienna meetup created a raffle, and you could win tickets for GeeCON 2016 in Prague. And I signed up for this raffle because I was already a member of the meetup group. And to my surprise, I won the raffle. So I got tickets. And first I was thinking whether I should go there or not. But I went to GeeCON Prague. And I met Dominic Dorn, which is the organizer of the Java user group in Vienna. And he said, well, you're the guy who won the tickets from this raffle, right? And I said, yes, I am the guy. Nice meeting you. And he said, well, how often have you been to the meetup? And I said, never. So he asked me to promise him that I will go there, bring a friend, and talk about something that is of interest to me. And that's what I did 6 or 8 months ago. And since then, I really liked it and applied for GeeCON Prague with this talk, and it was accepted. So having said that, you've heard in the morning that this is a community event, and the barrier for entry is if you have a well-prepared talk or a good idea, it's actually pretty low. So if you want to, I think if you want to talk, if you think about creating a talk and doing something similar in the future, I think it's a good idea to just try it, and maybe you like it, and maybe you will be here next year and the same way as I am today. Having said all that, I'm here to learn. I'm not associated with SonarQube in any way, so I'm just a user of this software. And if anyone knows anything better than I am, I'm very happy to hear your ideas and also the discussions and the questions afterwards. So I'll talk about code quality. So Baron Kelvin said, I often say that when you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the stage of science, whatever the matter may be. So the question is, how do you measure software quality? And the quality of software is actually, as we heard also in the keynote in the morning, is a multi-dimensional concept. So you have a lot of these ilities. You have functional suitability, performance efficiency, compatibility, usability, reliability, accessibility, and so far and so forth. And some of these factors you can influence. Some of these factors are things that you cannot influence as a programmer. So for example, as a software developer, you may only have impact on, for example, the quality of the code. But still, you write the perfect program, you write the perfect application. but maybe it's not. It doesn't meet the customer's needs. So what I want to say is that the quality of your software product is bigger than the quality of your code. But today I'm only talking about the quality of code. So this is taken from the ISO standard, and there's actually a model to try to make this more measurable. It's called the scale model, the software quality assessment based on lifecycle expectations. And you see there's quite a big overlap with testability, reliability. It's mostly about maintainability as well. And this model tells you how, so it makes the quality of code measurable. And it has been implemented in a few software products. This is also quite complex. So in reality, or in daily life, the measurement of the quality of a code maybe also looks like this. So the only valid measurement of code quality are the what the fucks per minute. So if you have good code, there's only a few what the fucks, and if you have bad code, you have a lot of what the fucks. It's happening here. SonarQube has a quality model based on the scale model, but they also adapted the quality model to make bugs, vulnerabilities, and code smells to first-class citizens. So they said the problem with the scale model is that even if you have major bugs and vulnerabilities and code smells, you could still overall get an A rating. And they wanted to change that. And you still have all these indexes in there, but bugs, vulnerabilities, and code smells are made more explicit. They define a bug as code that is demonstrably wrong or highly likely to yield unexpected behavior. A vulnerability as code that is potentially vulnerable to exploitation by hackers. And the code smell is something that will confuse maintainers or give them pause. And the interesting thing is that they not only provide these ratings, but also approximate remediation efforts. As you most probably also know, is that the earlier you catch a bug, the cheaper it is. So if you find a bug in the requirements phase, it's very easy to fix this requirement. If you find out that something's wrong in the requirement, or you introduce the bug in production, then this will be more costly. So the message is catch those bugs early in the process. On September 9th, 1947, Grace Murray Hopper records the first computer bug in her logbook as she worked on the Harvard Mark II, which was an electromechanical computer. So this is the bug there. I really like the picture. So in the SonarQube ecosystem, there are 3 lines of defense. So assume you're working locally. You're producing your industry average of bugs per 1,000 lines of code, which is approximately 15 to 50, so quite high. And the first line of defense of the SonarQube ecosystem is SonarLint. SonarLint is an extension of your IDE. It provides on-the-fly feedback. It's available for Eclipse, IntelliJ, Visual Studio, and Atom. It provides pre-commit analysis, so it helps you finding those issues before they make it to master. It can run in a local or connected mode, and it includes several languages depending on the IDE that you use. So you have local analysis with Java, JavaScript, PHP, and Python, and .NET with Visual Studio, and more with connected mode. Connected mode means that you connect your SonarLint instance to a SonarQube server, but SonarLint can run on its own as well. It looks similar, or it looks like this. you have your code, you have your SonarLint window. You can analyze all the files in your project, or only the open project, only the open files, or the ones that were changed after your last commit. You can also connect it to your SonarQube server, as I said before. If you do that, you can use the analyzers, the quality profiles, and the settings from the SonarQube server. So you have a shared custom rule set if you don't use the default rules. And it also supports additional languages in the connected mode. So this is your first line of defense. So you're working on your code locally. SonarLint raises some issues. You fix some of them. You don't care about the rest. You create a pull request, and there where the second line of defense of SonarQube comes in. And this is pull request analysis. So there are several plugins that you can use to provide you the pull request analysis capabilities. So you have to have a SonarQube up and running. You have to have a plugin installed on the SonarQube server. And you have to make it run for each commit, pull, or merge request. What it does is it creates a preview analysis. So it compares the code that is actually already stored in SonarQube with your commit. And it adds inline commits for each issue and a global summary. It updates the status of the analysis, and so human reviewers can focus on other issues. So for example, if you use GitHub or GitLab or Bitbucket, there are plugins in there for that. And you have to set it up in, for example, in GitLab, you have to install the plugin, set up GitLab in your SonarQube server, so you have to provide it information about the project ID, and the reference name, and then you have to link the project in SonarQube to GitLab, and for example run it with Maven or Gradle, and here runs the preview, the SonarQube analysis in preview mode, which means it doesn't actually store what you analyze in the SonarQube server, but it compares your commit with the last analysis in the SonarQube server, which is most probably master, if you set it up that way. As I said before, there are different plugins. Not all of them are in the SonarQube update center yet. So there's one for GitHub. This is actually written by the Sonar team. There's one for Bitbucket, one for Stash, and I think there are even two for GitLab. So this is the second line of defense. But so you fixed two of these issues that Sonar found, and you pushed it, and it made it to trunk. So this is where you start using the capabilities of Sonar to provide you quality gates and what they call fixing the leak. So for this, you need the SonarQube server. As I said before, also for the pull request analysis, you need the SonarQube server. SonarQube server is developed by SonarSource. It supports more than 20 languages. It has a very wide range of plugins. For example, for authentication, you can use your LDAP for that, or a GitHub account. It provides different source repositories, languages, and also external analyzers. It also supports external analyzers like Findbugs or PMD, but they claim, and I haven't checked it myself, but they claim that most of the functionality Findbugs and PMD provide is now already included in the Sonar Java analyzers that they developed themselves. And there are two versions. First one is latest. I have the impression that it's always in the middle of major refactoring. The next LTS is forecast for October 2017. So this is will be version 6. The next LTS version will be version 6.7. The latest version is now 6.5. And as I said before, there is LTS, which is the the long-term support version, I think it's now 5.6 or something. And if you use any of the community plugins, you should really use the LTS version. At least that's my experience. It's also available as a service. So they've recently started sonarcloud.io, and it's free for open source projects, and for closed repositories, you pay a monthly fee based on the lines you analyze. This is more or less how it looks like, but I will show it in a demo. The architecture works like this. You have your code on the left side, then you run you can run different SonarQube scanners. For example, you can run it via Maven, you can run it via Gradle, you can also run it from Jenkins or via a command line. It gets analyzed by the compute engine. Sonar itself uses an Elastic server to store some of the results, and then it stores so it interfaces with the SonarQube database, which can be an Oracle database or a Postgre database, MySQL or MS SQL. You can also set up quality gates in SonarQube. It's the best way to enforce a quality policy in your organization. It indicates whether your project is releasable. It's a collection of go, no-go decisions. And you can set it up in a way that each gate is a combination of a measure, a period, a comparison operator, a warning value, which is optional, and an error value, which is also optional. And it looks like this. For example, you can define that the coverage on new code over the last leak period, and I'll talk about it in a second, is less than, if it's less than 80%, for example, your test coverage, then SonarQube throws an error and your code doesn't pass the quality gate. You can do this for a number of measures that SonarQube provided, for example, the security rating or the maintainability rating. And then you can indicate, or then you can indicate whether the quality gate was passed or not, and could also act upon these results. What they started to push in the last versions is the concept of fixing the leak, and they have this analogy where they say, okay, if you have a water pipe and it breaks, what do? Do you reach for the mop, or do you try to find the source and fix it? So they say if you analyze your big project with SonarQube, it doesn't make sense to try to fix all the errors, but or the issues found, but more clean up over time and refactor your code over time and using this leak period. They visualize it like that. So you have the overall project results, and then it's compared, and this is highly configurable. For example, you can say use semantic versioning, and then you say you check in a new version, and then it compares the new bugs found. So you have the overall bugs, the new bugs found, the new vulnerabilities found, and the new debt found. So they really want you to focus on at least making your code not worse and improving it over time. It also provides detailed information about the bugs found, also who committed this code as it interfaces with the source code repository, the coverage, an indication of the effort to fix it, and a detailed explanation. So you get a list of all these issues, a list of all the rules, and you can activate or deactivate these rules. You have these quality profiles. They come built in, like the Sonar way of doing stuff is built in, but you can send up your own profile if you really want to, but then you also have to maintain it, of course. And then you can also, of course, administer the whole server. cool things I really like is, and they also blog about this, is that, for example, they can infer nullability. So, for example, here, process up here is null, and then it checks, it finds that here a null pointer exception might be thrown as process is nullable here. They also have introduced a new concept of cognitive complexity to analyze your code. And they say that cyclomatic complexity is very good to support or understand the testability of your code. So for each branch, you need a test case. But they also say that there are cases where the cyclic complexity is low, and it's still very difficult to understand. And they have a very interesting video how they come up with these numbers, and they count, for example, they add a point for nesting, and you get very different results if you compare the cyclomatic complexity and the cognitive complexity. And that's really interesting if you look at your most cognitive complex code and then also discuss it with your team members. What they've now also started in the new Sonar Java plugin is that they highlight the exceptional path when reporting the issue. So before it more or less looked like this. They said, okay, something is wrong, could go wrong here, but they didn't provide the additional information about the paths, or the possible paths. And now in the new version that was just released recently, you've got a numbering that, okay, here's number 1 and there's number 2, and that's why in number 4 a null pointer exception could be thrown because page is nullable here. There's some more goodies. What I really like is the OWASP 10 dependency check plugin. So if you use OWASP 10 dependency check, for example, the Gradle plugin, you can aggregate the results also in the SonarQube server. It also has Java 9 support. And you can also, for example, you can analyze your Scala code using external linters. So SonarQube is really now a place that can aggregate a lot of results, either from their internal analyzers, but also from external analyzers. Okay, so you fixed the bug, or the quality gate found the bug. And this is like the 3 lines of defense. But the question is, what happens if you do not pass this quality gate? So what you could do, and we did this in our company in the past, and it was highly controversial. And also the people from SonarQube says you shouldn't use it anymore. Is what you could do and still can do is you break the build. For example, if you run it on Jenkins, or your Jenkins is your integration server, for example, and you initialize a SonarQube analysis, and it doesn't pass the quality gate, then you could set it up in a way that it breaks your Jenkins build, and you cannot, for example, promote it to the next stage. I think an alternative of doing this is make the quality gate failures more visible. For example, with the pull request analysis, also you could use information radios for that. And you can also set up issue notifications. For example, you could set SonarQube up in a way that it sends emails to your, I don't know, your most senior developer, or someone who has ticket duty to check if there's a new bug. Learnings in the company I work in is for greenfield projects, it's perfect to start early. For legacy projects, don't try to fix everything. As I said before, fix the leak. Maybe also be a good idea to set up some exclusions. For example, if you know there's some code that you haven't touched in years, but it didn't really make any problem, maybe it's maybe you have to think about when is the right time to touch it, and maybe not touch it at all if, for example, the lifetime of the project ends before this gets a serious problem. You can also set up different quality profiles for a different project. For example, we had something like a legacy gate with some relaxed rules. What we also found out is I think you also need a culture change for doing something like that. So not everyone loves transparency. But it's very good. What Sony really provides is an objective instance with best practices. It also provides details, explanations, and I will show it you in a minute. And I also have the impression that it's good to stick to the default rules as long as possible. And if not, you really have a very good reason to deactivate any rules, for example. What's also important is to file false positives. So SonarQube will find some issues that are not issues. But what's also very interesting, and they get fixed very fast if you provide it to their feedback channels. That's important to create trust in the system, because if there are a lot of false positives, people they will blame SonarQube or the SonarQube server, and they will not even look into the issue before thinking that this is a false positive again. But what's also very interesting, that maybe you will even learn something about the language you use. So maybe the false positive, or the thing that you identified yourself as a false positive, is actually, after discussion on the SonarQube user group, not a false positive, but could indeed be a problem in an edge case, for example.
How do you handle this? Do you write no sonar to source code, or do you handle it sonar itself?
Say again?
This false positive, how do you manage them? Do you write no sonar to source code to this particular line, or do you...
No, yeah, the question is how to handle these false positives in Sonar. I think there is the possibility, or I'm not even too sure whether it still exists, to write no Sonar, like to have a no Sonar annotation, but I think it's not a good idea because it clutters your code base. What you also can do is, if the false positives get flagged, you can change it in the interface from a false positive to a false positives, or to a won't fix. But there might be the issue that after a big refactoring, these things are coming back. So I understand where this question is coming from. What's also important is to restore the built-in profiles after updates. So I was updating all the plugins every, I don't know, month. And after a year, I found out that actually we're not using the newest rules. I'm not too sure, maybe they have changed it now, but before that, the built-in profiles were not updated after you updated the plugin, so you had to restore the rules after the plugin update. And I've already mentioned that use LTS if you use any community plugins, or at least check the compatibility between the SonarQube version and the plugin repository. Having said all that, static code analysis with SonarQube is just one tool in your belt. I have a survey with me where they asked, what do you believe is the #1 thing a company can do to improve code quality? Code review is a #1, unit testing #2, functional testing #3, continuous integration #4, and static analysis is here at the end. But as I said before, if you set up this pipeline, you already have continuous integration. If you set up the pull request augmentation, you already most probably have code reviews, and you can also integrate the unit test results in the SonarQube server. So what it provides is a way to make your code more transparent. And I once heard that the biggest remedy against a big ball of mud is sunlight and transparency. So this is something that the SonarQube really provides. For summary, code quality is just one important aspect of software quality. Continuously inspect your code. Start with SonarLint today. It's really easy to set up. I'll show you in a second. After that, look into the pull request analysis and quality gates with SonarQube if you want to use that. Explore capabilities and extend functionalities with additional plugins. There are really a lot of plugins. And it's just a very powerful tool and no silver bullet solution. So for the last 10 minutes, I've created a short demo. And I'll use Docker for that. Yeah, Docker. So I'll just, it's the SonarQube, a SonarQube image is on Docker Hub. And you can just run Docker by typing docker run. It opens 2 ports, and I use the latest version, which is SonarQube 6.5. So it's, as I said, it's using Elasticsearch, and now it's starting. Of course, that could also be configured, but now for demonstration purposes, it's starting an HQ database, which is only which should only be used for demonstrative purposes and not for production. And it takes a few seconds. But in the meantime, I can show you SonarLint. So if you install SonarLint, it's a plugin for IntelliJ and also for Eclipse, as I said before. You will have a SonarLint tab, and it will provide you the capabilities to analyze all your project files, or only the ones that were changed after your last pull. And it also provides the capabilities to analyze the file you're currently working on. So for example, this is the SonarLint IntelliJ plugin itself. So I wanted to do a kind of meta analysis here. It used to be a very good example because there have been a lot of bugs in there, or a lot of issues that were detected by SonarLint, but they've really improved the plugin itself as well. And I use this example to also show you how it's set up. So this project uses Gradle, so you can just apply the SonarQube plugin. And then you can provide additional settings, but you don't have to. For example, you can set the Sonar project name, and if you don't do that, it will take, or it will use reasonable defaults. So for example, I created here a private static string, and then I set it in the constructor, and it will tell me here that you should not do that. And this is where also the learning experience comes in. I think that's very valuable for me, and I think also for junior, but also for senior developers. So it says here, assigning a value to a static field in the constructor could cause unreliable behavior at runtime, since it will change the value for all instances of the class. And then it even provides a non-compliant code example and a compliant solution. So it also provides a learning experience. In this case, it even indicates that the field I created here is not used anywhere and should be removed. So SonarQube is up. Yeah, this is how you get greeted if you open SonarQube for the first time. So you see here, you see a lot of the things that I told you today, that in the quality model, the bugs, vulnerabilities, and code smells are first-class citizens, that they really focus on fixing the leak and enforcing quality gates. and you could also it could also help you to follow standards. And there are different ways to analyze your code. For example, with the Gradle plugin, but there's also a Maven plugin. You can run it via Jenkins and even via Ant if you really want to. And I use I'll log into the SonarQube, and you get greeted by a tutorial, but I'll just skip it here. And now of course, it's empty now. As I said before, I use this in-memory database, but I will run the analysis from this project. So I just start Gradle with the SonarQube tasks. And what it does, it now builds the project. As I said before, this is the SonarLint IntelliJ plugin project. It also runs all their tests. Compiling. It runs all the tests and then runs the SonarQube task. And they've also set up GeeCON so that also SonarQube collects all these results from GeeCON, so they know which lines were executed by which test, and also provide you analysis functionalities to do that. So it's running the tests now. Yeah, now it's running the SonarQube task. And this is in the meantime, I can show you the plugin ecosystem of SonarQube if my network connection works. I hope it does. Yeah, so you see here the plugins that come installed with this Docker image. Some of them already got updates. But if you look at the available plugins, there are plenty of them. Some of them are commercial plugins, so you need a license for that. For example, they have a Swift analyzer, which is an enterprise plugin, but there's also a community a Swift plugin. Okay, this is ready. So now I have my project in here. I'll just introduce the bug again to show you the problem with, or the leak concept. So what I see here is the bugs and vulnerabilities. These are the most important. The most important focus is on the focus is on bugs and vulnerabilities. I can click on one of them, and similar to the SonarLint plugin, I get a detailed explanation why this could be a problem. So I see the path, and I also see an example why this could be a bad idea. I have to admit I don't know the code of this SonarLint IntelliJ plugin. It could be a false positive, of course. If it's a false positive, I could either so I could assign it to a user of SonarQube, for example, to a fellow developer. But I could also say I resolved this as fixed, or this is a false positive, or I won't fix that, or I can confirm it. I can change the severity of it. I'll close this here. So you get all the issues. Also, as I said before, we're running Chococo, so you see which paths are not covered, which paths are covered, and how many branches of the code are covered. The unit tests and how long it took to run them. You also have them in there. And then also the other indexes, for example, maintainability index. They also calculate a technical debt. So they say to fix all these code smells, it takes 8 days, 5 hours. They provide liability or reliability ratings and information about your unit tests, as I said before. If you use this over time, okay, it's done. If you use it over time, and here's the leak period. So if you use it over time, of course, it also provides you a very detailed insight of whether your code quality improved or if it got worse. So I introduced 2 new code smells, and since the previous version, so this is the leak period. So what SonarQube says is you should focus on the leak period and make each version of your code better. It's like the Boy Scout rule. So leave the fireplace in a better status that you found it before. And yeah, you can define all these quality gates here. You can set up different measures, provides different languages, and all of these rules, what I already said, provide code examples that provide a very detailed learning experience. So yeah, these are all the resources, and I will provide the slides. This is my contact. And so we are working in our company with continuous integration. And what I like is I want my colleagues not only to fix the build, but also don't forget to check Sonar. And that's my talk. Thank you.